In today's video, we're going to be showing you how to install this beautiful Cooper & Hunter 36,000 BTU ducted heat pump. This video is going to be a little bit different in that I'm flying from Salt Lake to Missouri to install this system at my brother's house, and so none of my specialty HVAC tools that I use in all of my regular videos are going to be used. Every single tool on this project is purchased on Amazon and shipped directly to my brother's house. So I wanted to duplicate what this could be like for you. Now, to give you an idea on the savings involved here, my brother got a quote from a larger HVAC company to convert his gas heater to a heat pump system similar to what we installed here. And he quoted him $14,000 materials and labor to do that job. If you were to purchase this equipment, it's about $3,800. And we spent about $1,000 in tools and other equipment needed, such as the wiring and various sheet metal items, and we still came in at about $5,000. So that's a total savings of about $9,000. So I'd say it's absolutely worth it if you can purchase this equipment and have the mechanical knowledge to be safe about it and do this job yourself. You could save upwards of $9,000, and that's pretty epic. So let's get right into this install. All right, guys, so here's our equipment. This is the existing furnace. It's an old 90% furnace from like early 90s, I think 91. So we're gonna be dismantling this guy, and we should have plenty of room. We've got the existing AC as well that we're gonna show you how to pump all of the refrigerant into that unit. Now here's the new 36,000 BTU Cooper & Hunter air handler. This is all variable speed, so the motor is very sophisticated. It's able to adapt, and this has a smart thermostat that's extremely easy to install. Down here we have our refrigeration connections, and this is really nice. I didn't realize that these had this until I opened up the box, but a 20 by 20 filter fits perfectly in here, and then it just has this little magnetic cover, and it's as easy as that. This is going to be propped up, being as we can't do a side entrance filter. We're going to have a box right here, and then the unit will sit right on top of that box. Now, the means by which we're going to be building this box is this sheet metal right here. We got this for about 70 bucks at Menards. Lowe's and Home Depot, I noticed they sell some just regular square pieces that you can cut to build a transition or a box like we're going to show you how to do with this. But this one conveniently has these already built in. So we're going to utilize that and build our box. So we'll show you that process. So this is a 15 kW heat strip that's going to mount inside, and it has two 60 amp breakers. The likelihood of having to use this is pretty slim, but it's nice to have this for emergency heat. But this system is supposed to work down to negative 22 degrees. So for now, what we're gonna do is we're gonna kill power at the breaker box for our furnace. We're gonna disconnect the gas, cap that, and we'll get all of this removed. But the first thing that we're gonna do before any of that is we're gonna show you how to pump the refrigerant into the condenser so that we can remove this coil and not have to worry about refrigerant. I wanted to take just a second out of this video to talk to you about something that has saved me so much time and energy, and that is Jobber. As some of you may have already known, we just hired our first employee, and it has been so helpful to be able to schedule jobs on Jobber. I can simply select the customer, type in what type of job it is, if it's a maintenance or an actual service call, schedule it for a certain day and time, and my employee automatically sees that on his end, and it makes my job so easy. Another thing I really appreciate about Jobber is their request form. I use this almost on a daily basis, and it saves me a ton of time. So if you're in the service industry and you're looking for a CRM to manage employees, invoices, handle job requests, Jobber is a truly amazing software, and I highly recommend it. Check them out in the video description, where you can get a 14-day, zero obligations trial to make sure that Jobber is a good fit for you. Buddies. All right, so this is our old condenser. This is super ancient as well. This is our new Cooper & Hunter Hyper Heat system. This is a 36,000 BTU heat pump, so it will function in cold as well as hot weather. Thankfully, this unit is still functional, so we're gonna show you how to pump everything into the unit. One of the main things that you'll need for this process is a set of gauges. I think I got these for like 30 bucks. So I'll leave a link in the video description. So if you notice on the back side of our unit here, we've got these two king valves, and this is what keeps the refrigerant in the unit when it comes from the factory. So basically what we're gonna do is the reverse of that. We're gonna remove these caps, we're going to close the high side, and once we turn the unit on, it's gonna suck all the refrigerant into this side, and then we're gonna lock it in with this valve here. So let's go ahead and start by removing these caps. So what we're gonna do first is we're gonna close this one completely. So we're gonna tighten it all the way until it stops. All right, so our liquid line is closed all the way, and on our suction line, we closed it and we backed it off a couple turns. Now we're just gonna leave this wrench in here for when we're ready. Now what we're gonna do next is we're gonna take off the service port here on the suction side, or the larger side, and that's where we're gonna connect our blue hose from our manifold gauges. All right, so on our gauges, as you can see, we've got a reading. And now we're gonna show you how to start the condenser manually, and we'll watch this gauge go all the way to 0. And once we're at 0, we'll go ahead and lock this Allen key and contain everything to the unit. All right, so inside the actual unit here, we see our capacitor. And again, this is still live. We haven't disconnected this, so be really cautious if you're doing this yourself. Right here, we have our contactor. And basically what happens when the unit comes on and this calls for cooling is these two wires energize, and these two little pins here get pulled in. That's the whole point of this contactor, and it allows power to flow from here to the actual condenser and the fan. So what we're gonna do is use just an insulated pair of pliers or a screwdriver. We're gonna push this contactor in, and we're gonna hold it until our condenser pressure is down to 0, maybe a little bit into the negative, and then we'll lock it all in right here. So let's go ahead and do that. There we go. You already see our pressures dropping. So we're down to about 100. All right, we're just about at 0. So we're gonna go ahead and start locking this. All right, so that's it. Everything is locked into this unit. As you can see, we're staying at 0 on our gauge. So we're good to go ahead and disconnect the electrical, cut the lines out here as well as inside, and we can get our new equipment fitted. So we got our unit moved aside here, so everything's ready to go. I think we're gonna utilize that hole there. So we're gonna mount our new disconnect, run our whip up to the new unit and the refrigeration lines there. So here's where we're at. We've got the electrical disconnected, gas, all the venting is done. This piece was part of the actual furnace. So we're removing these screws here, and this whole thing should come off. And then we're just gonna remove this top sheet metal for the evap coil, and then we should be ready to slide this out. So as far as the communication wire, this doesn't matter on your old furnace if you're installing the Cooper & Hunter ducted system. Basically, all we're gonna be using is 2 of these wires that go up to the thermostat. So as long as you have 2 wires, even if you just had a gas furnace, you can totally run your brand new inverter heat pump just off of these 2 wires, and the thermostat communicates with this and the outdoor unit simultaneously, which is really nice. All right, so we got everything removed here. Everything's been cleaned up real nice. So we've got a nice blank slate for our new air handler. We got our sheet metal laid out, and we've got the box that we're gonna build laid out right here. So it's gonna be a 21-inch wide box by 22 1/4, which is the width of our return air duct there. And it's gonna be 16 inches high. So we've got 4 of these, and we're going to lay this out, make our cuts and our bends, and we'll show you exactly how to do that in case you need to build a box on your setup. Okay, so we made our marks here. So we added 1 inch here so that we can bend this and have our total measurement will be from here to here. Extra. Now what we're going to do is cut this 1 inch in and cut this off. Just like that. Now we're going to flip this over and we're going to bend this in 90 degrees. Just going to slide this on and we're going to slowly work this side to side. Until we have 90 degrees. Like that. What we're going to be using here is a Hillmore pocket brake. So this is just a weighted roller and you need a soft surface to do this on. And we're just going to walk this across. And what it's going to do is it's going to push this out so that you don't have this, you have more rigidity to this piece. And we're going to do that to all 3 sides of this box. So we're just going to kind of eyeball it. Make sure it's going the right way here. Give it some pressure. And you can see the sides coming up. Same thing on this side. Just like that. Now as you can see, it has a lot more rigidity to it. So this is going to be our front piece. So we're just going to slide it in. Good. Should we do the bottom?
Yes.
All right, so here's our box so far. This old one had a lip that bent down, so that went right into the S on the bottom. So everything is zip screwed in. We're going to caulk the bottom so that none of this vibrates on the floor when it runs. And then we'll seal everything up with duct sealant on this side and in here, and then we'll be ready to put our unit in place. All right, so our box is in place. Everything is zip screwed. We're just gonna seal all of these joints where it meets our ductwork with this duct sealant that comes in a tube. We got this at Menards, and you can get it at Home Depot or Lowe's as well. So we're just gonna fill any joints with this. All right, so this is our finished box here. Everything is sealed. On this end, we had to add this little filler piece because our return duct was wider than the furnace itself. So we double folded this. It's nice and rigid. So we're gonna go ahead and set this on here, and we should be just within an inch of this top piece. I don't think we'll have enough to build a transition, but we have mastic tape, so I think we're just gonna seal it. And it's the exact same dimensions as our supply duct here. So we just got this guy in place and it fits perfect. We did some duct sealant on the box before we set this in place. So we're gonna do some mastic, and the inside is sealed completely. You can see it bubbling out right there. We have a little bit of an overlap, but that's totally fine. And then up here, we're literally right on it. So we're just gonna do some mastic here and we'll be golden, as long as we have access to removing our front covers here. All right, so we got the bottom all sealed up. Everything looks really nice here. We're just starting to mastic the top, and I just wanted to show you a little trick. So we took this long strip and we basically creased it in half, and it'll stay rigid. We fed it in, and then I'm just gonna use this S-drive with some tape over it to get this squeegeed out right here. We're just gonna go through and mash this against the duct, and that's gonna keep it stuck. All right, so all of our sheet metal work is done. Our box is good and sealed. The top is done with mastic. It was a perfect fit on that, so that was really easy. We have the front cover off here. The first thing that we're gonna do is we're going to install our heat strip kit. So this came with it. It's a 15 kW heat strip. And as you can see, it's got two 60 amp breakers. And then this is the connection for the fan. All of these are 220 volts. As you can see, the gauge for the wiring here is pretty small. The fan doesn't require a lot of amps. However, the two breakers for the 60 amp for the heat strips, those require a 6-2. So we got this from Menards as well. So we're gonna run 2 lengths of this to our new breakers at the breaker box. But we'll go ahead and get this put in. So to do that, all we have to do is take off these 2 screws here. Okay, so we got that cover pulled off. So what we're gonna do now is install the new heat strip. And this little bracket right here is gonna go towards the bottom. You basically need to line up these holes. And once you hit those 4 prongs in the back of the furnace, this will go in all the way. All right, so we've got all of our electrical connections made. Our conduit looks really nice. So as far as the electrical, I wanted to show you how this is wired. So the condensing unit powers the air handler just like any other mini split installation. So these are the communication wires that came with the line set. So we have a ground, L1 and L2, so red and black. The white is not used, so don't worry about that. That's only for commercial applications from what tech support said on that. And then the thermostat wire, this is the existing thermostat wire that goes to the thermostat. So we have HA and HB. These are the only 2 terminals that need to be connected to communicate between the thermostat and the air handler, which is pretty awesome. So this is the Cooper and Hunter thermostat that makes this job really easy. And as you can see on the back, these are the only 2 terminals you have to wire, HB and HA. Now these 2 back here, it's hard to see them, but S1 and S2 on the board, they simply go out to the condensing unit to S1 and S2. So when we go out there, we'll show you how that looks, and it's really easy to make that connection. Our conduit is finished up, looks really nice with the liquid tight connections there, although this is indoors. It just makes for an easy connection there. And that's pretty much it. All right, so we're just getting our line sets fitted here. And this is a 5/8 and a 1/4 inch line. So the 1/4 is really easy to bend. You don't have to worry about kinking. But on this one, you want to be a little bit more ginger when you're bending these. So you can cut the insulation or you can pull it back just to confirm that you don't have any kinks. So after we bend this, we might cut some on the inside of these just to confirm. But I'm basically just slowly making these a wide bend, and we cut the insulation so that these are not connected. And we're just doing a wide bend, so if it comes up a little bit, that's totally fine. I'm just working one at a time here. Feed this in a little bit. Should be pretty close. All right, so we're working on our line set. We got it fastened all the way and bent at the condenser, and it was the perfect length. We didn't have to cut anything. So once we have these connected on both ends snugly, we'll kind of get this looking pretty. So we're ready to put the front cover on. All of this is done. We're about to connect the line set here and at the unit, after which we can pull our vacuum and introduce the refrigerant. All right, so we're just gonna remove these caps. This should have, yeah, it's got nitrogen. So that's what we're looking for. These are pre-charged with nitrogen. That makes sure that these coils do not have any leaks from shipping. So we're just gonna let that bleed off. All right. All right, so our electrical is done. I just wanted to show you what this all looks like. So we have our two 60 amp breakers, and these two 60 amp breakers are for our emergency heat. The white has been wrapped to signify that it's not a neutral. These are both power legs. And then we have our two grounds hooked up there. And then on our breaker, for this particular one, it called for a 40 amp breaker. So we have number 8 wire running up and over. That's going to go out to our disconnect, and that's for our AC. Also, the condenser, this breaker goes to the condenser, and the condenser powers the air handler. That's why it's a larger breaker, because they're not on separate circuits. So we're ready to put our cover back on, and this portion is completely done. All right, so out here at the exterior, we have our little chase thing here to keep this from rubbing against the aluminum siding. And then we are probably gonna do a bunch of silicone here now that everything has been fastened inside. And then what we're actually gonna do is we're gonna mount this right here, and we have a plastic bushing that fits in this 3/4 hole here. So once we have this, we can mount it silicone around and make sure that everything is sealed. And then we're going to have everything included in this 3/4 conduit. So we have some additional space here, as you can see. So we're just gonna feed this line for the air handler and this thermostat wire through there, and that'll make for a really clean look when it's finished. So for now, we're gonna seal this off and then get our box mounted. All right, so here's a little progress report. So we have our cover there for our line set, turned out really good. We have our liquid tight 90 degree, and we're gonna go up there to the unit, all with one single 3/4 conduit. This is the power that comes in from our breaker panel. So this is gonna go to the line side, which is the middle two ports there. And then the ground will go here. And then this side is for the unit or the load side. So black and red will go to these two here. Polarity does not matter on those. They're both line voltage. And then our ground will go right there. So once we have this buttoned up, we can put our covers back on, and we will be ready to wire it up here, and then we can pull our vacuum. All right, so our disconnect is fully finished up here. So this one, if you remember on the inside, this was not being used, so it doesn't really matter. I noticed I cut that, but we're not using that. It's not attached on the other side. We have our two lines in the middle, two loads on the outside, and both grounds here. So we can go ahead and put this little cover in, and this is completely functional and ready to go. All right, so while we're working on the electrical here, I can show you this real quick. So we have our wiring fed through here. This is an issue. We need to get some connectors to attach to these ends to crimp them, and then we'll attach them just like these ones up here. These ones will probably be fine if we just go under the little connector there, as they're a really small, probably 14 gauge wire. So anyways, while we're working on this electrical, we're going to be pulling the vacuum. And again, all of this stuff is items that you can easily purchase yourself We ordered a vacuum pump and had it shipped out here to Missouri, but they lost it in shipping. My brother had this one. It's just a cheap eBay one, 4 CFM, and these are the gauges that we purchased. Now, one thing that's really important, and I've run into this myself in the past, you cannot make a makeshift adapter if you don't have one, because you need the core depressor. So this adapter came with the gauge set that was like 40 bucks, 50 bucks, and it just screws on to a 5/16 and it depresses the valve core, allowing this to have access to in here. So sometimes if you don't have that, you could be pulling a vacuum on this hose and not even be pulling a vacuum on this. So you want to make sure you have this adapter. The other critical thing is the micron gauge. So this was a Hillmore one that we ordered and had sent here. It was about $130. Really nice backlit display. So this is going to gauge how good of a vacuum we have, and it also acts as a pressure test. So once we crank this up, we'll watch these numbers drop, and the target is to get below 500 microns on the system. Now, the way that we're routing this is different than what I normally do at home. We're just gonna open both of these, and this is going to take a reading off of here. Normally I like to put this on the high side, but being as we only have one port, we're kind of limited to this, but this will still give us a good reading of, or a good gauge of how we're doing as far as getting all of that moisture out. So let's go ahead and turn this on. I'm gonna open up our gauges here. You hear the pitch change because now we're sucking all the moisture out of the lines and the evaporator coil. So it's been a couple minutes and we are dropping pretty rapidly. Really like the simplicity of this gauge. It's compact, has a nice backlit display. So we're gonna give this a few more minutes and see what we can get down to. I just wanted to give you an update on this. We got our PVC done. You can choose to put a safety switch here, but we have our drain pretty close by, and we're actually using a condensate pump on this one as well. So we have this, our P-trap is here with a clean out, so we can clean that out if needed. Goes around, and we have our condensate pump there. And we're working on installing an outlet here for that condensate pump. Everything else is pretty much done in here. We went ahead and stuck the schematic for our heating element there, and the conduit for this turned out really nice. So everything looks really good so far. We're waiting on our vacuum, and as soon as our vacuum gets done pulling, this system will be ready to let the refrigerant in and we can start it up. Oh guys, it's decided it's gonna rain on us, but I just wanted to show you the finished product here. So we've got L1, L2, and ground. That's for our high voltage. This is the communication and power that goes to the inside unit. And this is the S1 and S2 that goes from the indoor unit to the outdoor unit. So now that this is completely done, we're gonna go ahead and reattach this here. It's just been about an hour. I'll show you where we're at here. 638. So we're getting real close to our 500 micron mark. And afterwards, we'll go ahead and let the refrigerant in. All right, so our vacuum is good to go. We're gonna close this ball valve right here. And we're good to go ahead and introduce the refrigerant. So we're simply gonna open this all the way. And we're gonna do the same on the high side. And that's it. We're gonna let this refrigerant stabilize for about 10 minutes and we'll give it power and we'll test it out. All right, so we just bumped the system on. We're set to 72 degrees. We're set to auto. So we'll see what it does. It's 66 degrees in here. So we set this thermostat at 66 degrees. It's already at 70. And as you saw, we're blowing 110 degrees out of the vents. This thermostat is really nice, really easy to use. The mode function cycles from cooling to heating to dry and auto mode. Since we're in the winter time, we're just gonna leave it on heat. Well guys, we're finished up with this install. As you can see, we ran out of daylight, but everything looks really good. We're pulling 43.5 degrees. And as you saw inside, we've got about 114 degrees coming out of the vents. We're gonna test out the heat strips and make sure they're working like they should, but everything is good to go. Our line set was the exact length that came with this system, so I'm not gonna worry about checking the charge, and everything is buttoned up and ready to go. All right, so our breakers are on. Everything checked out really good with the regular heat pump. We're gonna just bump this up a couple more degrees, and we're gonna go over from heat mode to auxiliary. As you heard, I think the fan just kicked off. So we're gonna give it a minute and see what's coming out on auxiliary mode. So this is our finished product here. We've got our drain with our P-trap and our clean out there. The line sets turned out really nice. We didn't have to shorten or lengthen or anything. The conduit is beautiful. All of our wiring is contained into these two, including both of our heat strip wires, which are pretty large 6-gauge wires. And then up here in the front, we have this cover over our two 60-amp breakers here. Now, if you'll notice right here, we have a little display. You can flip this open or closed. If you have a issue, you can look in here and you'll see a fault code. And if you don't have any problems, you'll just see the temperature that it's set to right there. And then over here we have our breaker panel. Again, we've got our HVAC breaker right here, and then we've got our two emergency heat 60-amp breakers here. So everything turned out really nicely in here, and we still have a slot left. And even if we wanted more of these, we could reduce these with those double breakers and open up a bunch more slots here. So a couple of things I wanted to mention here with this install that I didn't know prior, and I think you will find beneficial, is if you have an existing furnace that already has 110 power going to it, you can actually utilize that wiring on its own breaker, and you don't have to run that black communication wire from the condenser to the new air handler. You can run the existing breaker and simply run it to those three T1, T2, and ground, and just make sure that it's a 220 breaker, not a 110. Otherwise, the system just is not going to function. The other thing is you can actually purchase a box, a return air box that you can put under that air handler for about $130. So if you don't want to even hassle with having to build a box, we spent almost that much just getting the sheet metal to build it. You can get one that's already pre-built. I think all of them are 21 inches wide out of the box. And you can simply put that in place, cut a hole for your return, attach it, and set your unit on top. And that probably would have saved a couple of hours out of this install. Definitely worth an extra $130. The third thing that we found was that we had everything wired for the electronic backup heat strips. And that night before we left, we tried to power them on and nothing was happening. And so the next day I had my brother just try it again. And sure enough, the electric power strips work perfectly. So I think they're on a time delay. So just make note of that if you're installing the electronic backup heat. That's gonna be beautiful. If that heat pump ever fails, he will have an auxiliary mode to heat his home. Now with that being said, if you're interested in seeing how a dual fuel installation looks, check out this video right here, and we're gonna show you how to replace your air conditioner with a heat pump that will function in heating and cooling. And we reutilized our gas furnace as our backup heat. So should the heat pump ever fail, our gas heat can come back on and heat the home. Until next time, you guys be safe. Later. Stop that.
What are you doing? Sit down.
He wants to be in a movie.